Good morning, students. Welcome back to math class, lecture number 2 in logarithm series. In this video session, we will recall the formulas that we have seen earlier in first lecture, and we will also discuss some more examples related to the other rules which are left to be discussed in this video session. So this is the list of all the formulas that we have discussed during our first session. Now let's quickly look at the rules. Number 1, log 1 is 0. Log 1 value is always 0. If number is 1, then log value of logarithm function is always 0. Number 2, if number and base both are equal, then value of logarithm is 1. Number 3, if number has any power, it will be shifted into multiplication front side. If base has some power, then its reciprocal will go into the multiplication. Number 5 is a raised to log x base a is equal to x. It means whenever index and log functions are together with same base, they remove the effect of each other and answer is the number itself. Number 6, whenever multiplication of log function is given, it can be separated as addition of log function with same base. Similarly, number 7, division is converted into subtraction. Number 8 is change of base formula. So in this video session, our focus will be particularly on examples related to 6 and 7. Rule number 6 and 7. Generally, when we are dealing with such type of examples, we have to apply the rule in reverse order. It means what? If you look at the rule number 6, in question it will be given like this: log x plus log y, and in place of that we will write log x into y. Similarly, when log x minus log y is given, we will write log x divided by y. It means addition of separate log functions will be converted into multiplication with common log. Subtraction of separate log function will be converted into division with common log function, provided base are equal in each logarithm function. It means you can see that on right hand side, log x and log y both are having same base a. Only then we can apply this rule. If one of the function is having base a, other function is having base b, then the rule cannot be applied. So be careful about this thing, and obviously rule number 1, 2, 3, 4 will be useful when we are solving the examples using rule number 6 and 7. So let's proceed for the examples. First question is: find out value of log 63 divided by 27 plus log 36 divided by 49 minus log 72 divided by 42. This is given to us. We have to find out value. So as I said, whenever addition, before we proceed to solve the example, you can observe that all the three log function do not have base. Base is not mentioned anywhere. So by default, base is e. As we have seen in our first lecture, whenever base is not given, the base is considered to be e. It means that all three functions are having same base. So we can apply rule number 6 and 7 here, and according to rule number 6, the addition will be converted into multiplication with common log function. So we can write down this is equal to log, for the first two terms I am writing log 63 divided by 27 into 36 divided by 49, and third term I am keeping as it is right now. We'll proceed for it later. So I have used only one rule here, that addition is converted into multiplication. Okay, now here you can simplify these terms. It means whatever can be cancelled out, you may. For example, 36 is in numerator, 27 is in denominator. We can cancel out 9 from both of them. Similarly, 63 is in numerator, 49 is in denominator. We can cancel out 7 from both of them. So you may cancel all the terms which may be inside the bracket, and then we left with log 12 by 7 here and minus 72 by 42, log 72 by 42. Okay, now we have subtraction of two log function. So according to rule number 7, it will be converted into division with common log function. So log 12 by 7 divided by 72 by 42 using the rule number 7. Okay, now we know that if 72 divided by 42, we take it into the numerator, it will be converted into multiplication with inverse of this term. It means we can write down 12 by 7 into 42 by 72. This term in denominator we are taking into numerator. Again, cancel out all the things which can be. So here 12 into 6 is 72. 7 into 6 is 42. So I think everything will be cancelled, and inside the bracket we left with 1. So we have log 1, and we know that log 1 is equal to 0 with any base. So this is our final answer. Question was find out value of this term, and value is 0. Okay, let's move towards the next example. Find out value of log 12 base 18 plus log 9 base 18 plus log 3 base 18. Addition of three logarithm function is given, and all three are having same base 18. It means using the rule number 6, this addition will be converted into multiplication with common log function. So we can write down this is equal to log 12 into 9 into 3 base 18. Multiply all the numbers inside the bracket. So we get log 324 base 18. Now question is find out value. It means we have to do something to remove log function, and for that we will, if you remember the first lecture, we will convert 324 in terms of some power of 18. Check is it possible or not. So you may use a calculator and you will find out that 18 square is 324. So in place of 324 we can write down 18 square. Now 2 is the power of number, so we can shift it into multiplication with log function, and log 18 base 18 will be equal to 1. So final answer is 2. Let's take another example. Prove that log of root a square plus 1 plus a plus log of root a square plus 1 minus a is equal to 0. Now in this question they are saying that prove this is equal to 0. Whenever prove that type question appears, start with one side and move to the other side. So here we'll start with left hand side. Left hand side is equal to this. It is given to us, and finally we should proceed in such a way that our final answer is 0. Then we have proved our example. So this is given to us. Here you can see that two log functions addition is given. Base is not mentioned, it means it is E and it is same. So addition is converted into multiplication with common log function. It means we can write down log of single log function inside the bracket multiplication of two numerals which are given. So root of a square plus 1 plus a and root of a square plus 1 minus a. Okay, now you have seen this rule during your school that x plus y into x minus y is equal to x square minus y square. So using this we can write down log of first term square minus second term square. Now first term is root of a square plus 1 square and minus second term is its square. Okay. Now if we look at the first one, then it is having square root and square both. So both of them will be eliminating effects of each other. It means we left with a square plus 1 and minus a square. Now open the bracket. So plus a square and minus a square will get cancelled, and we left with log 1, and value of log 1 is 0. It means we have obtained the right hand side. So this is the proof, or we have completed example number 3. So let's move to the next one. Simplify log x square divided by y plus log y square divided by z minus log x divided by z square. Before we start the example, if you look from the starting of this lecture, this is the third type of example. How then? First type of example we have seen was find out value. Generally, whenever question is related to find out value, as answer you will get particular number. Now that number may be 0, that number may be 10, 15, 20, 35, anything. Second type of question we have seen, prove that type example, in which we start with left hand side and we obtain right hand side, or we start with right hand side and we obtain left hand side. And this is the third type of example where they are asking to simplify. Now look at the word simplify. It means we have to minimize the expression as much as possible. Not necessary that we will get some particular value, but we have to try to simplify this expression. We have to minimize this expression as much as possible. So one more time, you can see that log function is not having any base mentioned here. So base will be by default e. It means it is same base. So addition will be converted into multiplication. Subtraction will be converted into division. So both steps are performed together here. You can see that this is addition of first two. So it is multiplication with common law, x square divided by y into y square divided by z, and the subtraction results into division. So it is in denominator x upon z square. Now let's take the denominator into the numerator. So it will be inversed. It means we get log x square upon y into y square upon z into z square upon x. Now cancel out the things which you can inside the bracket. So single time x will be cancelled, y and z, all three single time in numerator and denominator get cancelled, and we left with log of x, y, z. Now any further simplification is not possible here. So this is our answer. Okay, because nothing is possible now. If you use rule number 6, then you may write down log x plus log y plus log z. But in that case, again, it is not simplification. You are expanding the term. So this is our final answer. Let's look at the last example for this session. Find out value of log x upon y plus log y upon z plus log z upon x. Here again, base is not mentioned. It means it is e, and all three terms are positive. It means they will be resulted into multiplication of terms. So log of x upon y into y upon z into z upon x. Now cancel out what can be cancelled inside the bracket. So you can see that y will be cancelled, z will be cancelled, and x will be cancelled. It means everything inside bracket gets cancelled, and we left with log 1, and log 1 is equal to 0. So this is the answer. So these are the examples related to rule number 6 and 7, and one of the very important concept. If you look at the point of examination, every time examination will have such type of question. So do more practice to get better results in this concept. So in this video, we have discussed about the rule number 6 and rule number 7 related examples, and in next lecture we shall discuss about the examples of last rule, change of base in logarithm. Thank you.